Preparing for AI agent engineer interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you design a production-grade AI agent? I would design the agent as a controlled loop around a language model, not as an unrestricted chatbot. The system would include typed tools, short-term state, optional long-term memory, explicit termination rules, and approval checkpoints for risky actions. I would add tracing, token and latency metrics, retries, timeouts, and fallback models. Tool permissions should be scoped per user and task. Finally, I would evaluate complete workflows, because component accuracy alone does not guarantee dependable behavior. While answering, cover the model layer, tool interface, planning loop, memory, state management, orchestration, observability, guardrails, failure handling, authentication, and deployment considerations for reliable production operation. Question 2. What is the difference between an AI agent, a chatbot, and a workflow automation system? A chatbot primarily generates conversational responses, usually without taking meaningful external actions. A workflow automation system follows predefined steps and is highly predictable. An AI agent combines model-driven decisions with tools, memory, and feedback to choose actions dynamically. For example, a support agent might inspect an account, search documentation, and issue a refund. I prefer workflows for regulated, repeatable tasks and agents where inputs are ambiguous. Many strong systems combine both: deterministic boundaries surrounding flexible agent reasoning. Make sure to distinguish conversational response generation, deterministic process execution, and autonomous decision-making. Discuss planning, tool usage, state, adaptability, predictability, and when each architecture is appropriate. Question 3. How does tool calling work, and how would you make it reliable? Tool calling lets the model select an operation and provide structured arguments, while application code performs the actual action. I define strict schemas, validate every field server-side, and authorize against the current user and resource. Tools should return concise, typed results and actionable errors. External calls need timeouts, bounded retries, and idempotency keys for mutations. I also log tool selection and outcomes, but redact sensitive data. The model proposes, trusted application code decides what is permitted. In your answer, talk about structured schemas, argument validation, authorization, idempotency, timeouts, retries, error messages, observability, tool descriptions, and preventing unsafe or unintended side effects. Question 4. How would you implement retrieval-augmented generation for an enterprise agent? I would ingest authorized documents, preserve metadata and document relationships, then create semantically meaningful chunks rather than splitting blindly by characters. Retrieval would combine keyword and vector search, followed by re-ranking and permission filtering. The prompt would require citations and explicitly allow the agent to say it lacks evidence. I would monitor freshness, duplicate content, retrieval recall, groundedness, and answer usefulness. For sensitive enterprises, access control must happen during retrieval, not merely in the final prompt. Be sure to mention document ingestion, chunking, embeddings, metadata, hybrid retrieval, re-ranking, access control, citation quality, freshness, and evaluation against realistic enterprise questions. Question 5. How do you manage memory in an AI agent? I separate memory by purpose. Working memory contains the current task and recent tool results. Episodic memory records useful past interactions, while semantic memory stores durable facts or preferences. I would write memories selectively using confidence and relevance thresholds, then retrieve only what supports the current task. Summaries control context growth, and timestamps help resolve stale information. Users need deletion and inspection controls. Credentials, sensitive data, and unverified claims should generally never enter persistent memory. While answering, distinguish working context, episodic memory, semantic memory, and user preferences, cover summarization, retrieval, expiration, privacy, contradiction handling, and deciding what should never be stored. Question 6. How would you prevent an agent from entering an infinite or inefficient reasoning loop? I enforce budgets at several levels: maximum iterations, wall clock time, tokens, and tool calls. Each step records an action fingerprint, so repeated searches or identical tool arguments can trigger a stop. The agent should have explicit completion criteria and receive structured tool errors rather than vague failures. If progress stalls, I switch to a fallback response, ask the user for clarification, or escalate. Traces make inefficient loops visible, enabling prompt, tool, or policy improvements. In your answer, cover maximum iterations, token and time budgets, progress detection, repeated tool detection, explicit stop conditions, fallback behavior, and preserving useful partial results. Question 7. What strategies do you use to reduce hallucinations in agent systems? I reduce hallucinations by moving factual work outside free-form generation. The agent should retrieve authoritative context or call a source of truth tool, then answer only from returned evidence. Structured outputs constrain formats, and prompts require citations or an explicit uncertainty statement. I also validate important claims programmatically, such as totals or account status. Evaluation should include missing, conflicting, and malicious documents. A trustworthy agent is willing to abstain instead of confidently inventing an answer. Make sure to cover grounding, constrained generation, retrieval verification, tool-based facts, uncertainty handling, citation requirements, answer abstention, and testing with adversarial or incomplete information. Question 8. How would you evaluate an AI agent beyond measuring language model accuracy? I evaluate the complete task outcome, not just the final text. Metrics include success rate, correct tool selection, argument validity, groundedness, safety violations, latency, cost, and escalation quality. I build a labeled scenario set covering normal, ambiguous, and adversarial requests, then combine automated checks with expert review. Online, I monitor abandonment, corrections, repeated attempts, and sampled traces. A useful evaluation separates planning failures, retrieval failures, tool failures, and communication failures so fixes target the right layer. Discuss task success, tool correctness, trajectory quality, groundedness, safety, latency, cost, user satisfaction, human review, benchmark design, and production monitoring across representative task distributions. Question 9. When would you choose a single agent versus a multi-agent architecture? I start with one agent unless specialization provides a measurable benefit. A single agent has simpler state, lower latency, easier debugging, and fewer coordination failures. I consider multiple agents when tasks have genuinely different expertise, permissions, or execution boundaries, such as research, coding, and compliance review. I use a supervisor or explicit workflow to delegate, define typed handoffs, and cap recursion. Multi-agent designs can improve modularity, but they also multiply tokens, ambiguity, and failure modes. Be sure to explain coordination overhead, specialization, shared state, delegation, failure propagation, observability, latency, cost, and why a single agent is often the preferable starting point. Question 10. How do you defend an agent against prompt injection and indirect prompt injection? I treat every user message, document, web page, and tool result as potentially untrusted data. Retrieved content cannot override system policies or grant permissions. Tools run with least privilege, and sensitive actions require server-side authorization plus confirmation when appropriate. I validate outputs before execution and isolate browsing or code execution environments. I test direct and indirect injection attacks, including malicious instructions hidden in documents. Prompting helps, but security must ultimately come from boundaries outside the model. In your answer, cover untrusted content labeling, instruction hierarchy, tool isolation, least privilege, output validation, retrieval filtering, confirmation gates, and treating retrieved text as data rather than authority. Question 11. How would you design human-in-the-loop approval for high-impact actions? I classify actions by impact, reversibility, and affected resources. Reading public information may be automatic, while sending money, deleting data, or communicating externally requires approval. Before execution, the system presents the exact action, parameters, target, and expected consequence, not merely a vague summary. Approval is tied to an authenticated user, expires quickly, and is recorded in an audit log. I prefer reversible operations and risk-based thresholds so users are protected without approving every harmless step. While answering, discuss risk classification, approval timing, clear action previews, identity verification, audit trails, expiration, reversible operations, and avoiding approval fatigue through appropriate thresholds. Question 12. How would you optimize latency and cost in an agentic application? I first profile where time and money are spent, model calls, retrieval, tools, or serialization. Then I route simple classification and extraction tasks to smaller models, cache stable retrieval results, trim irrelevant context, and parallelize independent tools. Streaming improves perceived latency, while early exits prevent unnecessary reasoning. I enforce token budgets and use asynchronous execution where possible. Every optimization must be checked against task success and safety. The cheapest response is not valuable if it causes retries or human escalation. Make sure to mention model routing, prompt and context reduction, caching, parallel tool calls, streaming, early exits, batching, token budgets, and measuring quality before accepting optimization trade-offs. Question 13. How should an agent handle tool failures, partial results, and unreliable external APIs? I represent tool failures with typed categories such as validation, authorization, rate limit, timeout, and unavailable service. Transient failures get bounded exponential backoff, while repeated failures open a circuit breaker. Mutating operations use idempotency keys. The agent should preserve successful partial results, explain what remains incomplete, and avoid claiming success. If an alternative source exists, it can be selected under policy. Clear error semantics are essential because the model cannot recover intelligently from an indistinguishable error blob. Be sure to cover typed errors, retries with backoff, circuit breakers, timeouts, idempotency, fallback tools, partial completion, user communication, and distinguishing transient failures from permanent ones. Question 14. How would you choose between prompting, fine-tuning, and traditional software logic? I use traditional code for deterministic rules, permissions, calculations, and safety checks. I use prompting when behavior needs to change quickly or depends on broad language understanding. Retrieval supplies changing domain knowledge without retraining. Fine-tuning becomes attractive when I have many representative examples and need consistent style, classification, or tool selection behavior. I would benchmark each option on real tasks, including maintenance and operational cost. Fine-tuning cannot replace authorization or reliable business logic. In your answer, compare flexibility, determinism, data requirements, maintenance, latency, cost, and safety. Explain when business rules, prompt design, retrieval, or supervised fine-tuning are most appropriate. Question 15. How would you implement observability for an AI agent in production? I create a trace for every user request, with spans for planning, retrieval, model calls, tool calls, and final response generation. Each span records latency, token usage, model version, selected tool, and outcome, while sensitive content is redacted or access controlled. I track state transitions and termination reasons, not only HTTP errors. Correlation IDs connect agent activity to downstream systems. Production dashboards should expose quality, cost, and safety trends, with retention policies aligned to privacy requirements. Discuss distributed tracing, model and tool spans, prompts and outputs with redaction, token usage, latency, state transitions, error taxonomy, quality signals, correlation IDs, and privacy-aware retention. Question 16. How would you make agent-generated code or SQL safe to execute? Generated code or SQL must execute outside the agent process in a restricted sandbox. I default databases to read only, use parameterized queries, enforce table and row permissions, and set CPU, memory, time, and output limits. Secrets are never placed in prompts or source code. Execution receives narrowly scoped credentials. I validate generated plans before running them and require approval for writes or external effects. After execution, I inspect results for errors, sensitive leakage, and unexpected volume. While answering, cover sandboxing, read-only defaults, query validation, resource limits, allo lists, parameterization, secret isolation, human approval, result checks, and preventing access to unauthorized systems. Question 17. How do you maintain consistency and correctness across an agent's long-running tasks? For long-running tasks, I persist state after meaningful steps and maintain an event or action log. Each operation has an idempotency key, so retries do not duplicate effects. I use leases or optimistic concurrency to prevent competing workers from acting on stale state. If a step fails, the workflow can resume, retry, or execute a compensation action. On restart, the system reconciles with the source of truth rather than trusting memory. Durability matters more than keeping the agent continuously alive. Make sure to mention durable state, checkpoints, event logs, idempotent steps, compensation actions, concurrency control, resumability, leases, and reconciling actual system state after interruptions. Question 18. How would you design an agent's permission and identity model? The agent should never be a universal service account. I propagate the authenticated user's identity and evaluate authorization for every resource and action. For delegated work, credentials are short-lived, scoped, and issued only to approved tools. Tenant boundaries are enforced in databases and service layers, not merely represented in prompts. Policy decisions occur outside the model, with deny by default behavior. Every tool action records actor, delegated identity, resource, parameters, result, and timestamp for investigation and compliance. In your answer, discuss user identity propagation, least privilege, resource level authorization, tenant isolation, delegated credentials, policy enforcement outside the model, and complete auditability of every action. Question 19. How would you handle ambiguous requests from users? I distinguish ambiguity that changes the outcome from ambiguity that can safely use a default. For low-risk requests, I proceed with a stated assumption. For high-impact or irreversible actions, I ask a focused clarification question describing the available choices. I use conversation context, account metadata, and tool results to reduce unnecessary questions, but never invent critical details. A good agent makes uncertainty visible, minimizes user effort, and confirms the exact action before creating external consequences. Be sure to cover intent detection, clarification thresholds, safe defaults, confirming assumptions, user effort, irreversible actions, contextual follow-up questions, and communicating uncertainty without blocking straightforward work. Question 20. Describe how you would take an AI agent from prototype to production. I begin with a narrow task, measurable success criteria, and a deterministic baseline where possible. Next, I validate data rights, threat models, tool permissions, and representative evaluation scenarios. I build traces and offline tests before exposing real users, then launch behind feature flags with a small cohort and human escalation. Production gates include quality, safety, latency, and cost thresholds. I review failures weekly, improve tools or workflows before blindly enlarging prompts, and maintain rollback paths for every model release. While answering, cover problem definition, baseline workflows, data and privacy review, evaluation sets, threat modeling, staged rollout, monitoring, incident response, cost controls, and continuous improvement from feedback. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.